Okay, so our goal here is to create a small office, home office topology. It's a small office, but it's an office that has multiple sites and a firewall in each site, and at least a couple of VLANs, maybe 3 VLANs, and a few servers. So we're going to choose 2621 XM routers. So I'm going to pull one up here. Okay, so I'm going to go ahead and add in some interface cards here. Before I do that, I'm going to turn off the power. I'm going to add a couple of WIC 2Ts, so those are allow 2 serial interfaces on each router. And then I think we'll go ahead and do a 1 Ethernet network module here. We're going to power our router back up, and we're going to go ahead and close this for now. Now what I do want to do is highlight this, copy that, and then I'm going to paste it back multiple times. And this is going to give us the 5 routers that we need. And so here you can choose the different types of devices that you need. And so under end devices, we're going to need a actually, let's do just a server sitting here. And we'll have a couple of servers, one up here. And one there. We'll have one down here, and I'm probably going to drop this down just a little bit here. Give us enough room for our ASA here. We'll go back to network devices and come down here to security, and we'll do the 5505 right here. And back to end devices, and we'll pick up a PC here, 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 and here. We need a laptop up here. And we need back to network devices, and we'll do still seems kind of strange the way I do this here, but let's see if I can get this. Okay, so here's switches. And we'll do a couple of 2950 switches. One right here. And one right here. Okay, now we need to cable up our topology, and so we're going to use serial interfaces here. I'm going to go ahead and choose these here. I'm going to go from 00 on this one to 00 on this one. 01 to 01, and 00 to 00 on this one. Now, I'm just following the existing topology that I've created, so I want to be sure that I have the correct interfaces connecting from one of these devices to the next. There's nothing specific about choosing 01 or 00. I just want to follow the topology that I have. Now, we're going to change to a straight through, copper straight through. And we are going to do a straight through from Ethernet 10 here, and we are going to put it into 010. And we're going to go with another straight through. Actually, this one needs to be a copper crossover. We'll go from port 11 to port 11 on this one. We'll do a straight through from port 1 over to this machine, and from port 2 over to this machine. Port 3 over to this server, and actually I need to go from port 1 on this machine down to this device, and from port 2 over to this device. And we need copper cables going from the ASA, and we're going to do from 1 here to 00 here. Now, these particular cables here coming out of the ASA, we'll have to look when we actually start configuring whether or not these are the right set of ones to connect to. And we'll go here from Dayton Edge to the outside of this device here. And again, that's going to be another one that we're going to have to double check when it's time to actually configure it. So I'm going to copper crossover from the laptop over to fast Ethernet here. And again, we'll look at these as well, make sure we actually have the right ports connected based off the configuration that we are working from. Okay, so now we want to go in and actually make some configuration changes to the routers. We're going to start here with router 0, and we're going to click once on that. This pops up, and here at the top we'll go to the command line interface. And this approximates what you would see if you had consoled in using a console cable into the console port of the router. First thing that's going to show up, if this is a brand new router, is entering the initial configuration dialog, and that dialog is very limited. It's designed for people who don't know how to configure a router to be able to set your router up and get you connected to that if you're working from a different location as a network administrator in a different location. So we're going to put no here. And then we see press return to get started. And one of the things that's important about configuration at the command line is that you get one command here, one prompt, and that prompt changes depending on which mode you're in. And there's certain commands that can be entered only at certain modes. So right now we're in the user mode, we refer to it as user exec mode. And there's not a whole lot we can do here, but we can from here type enable. Now we can type the full word, or we could just type en, and you'll notice that the router prompt will change now, so that we have a number sign instead of a greater than sign. So that means that we are now in privilege exec mode. And we're now to the point where we can do things like, if we had configuration already, we could ping, or we could do things like that from enable mode. One of the things that we want to do right now before we get into interface configuration mode is actually to do a show run. So anytime that you need to see what the programming is on a router, you'll type show run. And you'll notice that there's a more down here at the bottom. If you press the space bar, you will get a full... If you press the space bar, you'll get a full screen of new text. You can continue to do this until you no longer get the more. Now you can scroll back up and you can see the configuration that we have on this router. So we don't have anything, but you will notice that we have interfaces. So we have 2 fast Ethernet interfaces, and we have 4 serial interfaces, and then we have that one 10 megabit per second Ethernet that we added in that network module. And I kind of do that just to show you some different interface types. So you can have Ethernet, which are 10 megabit per second, or you can have fast Ethernet, which is 100 megabit per second, or then you can have gigabit interfaces. And all these interfaces are configured the same way. You just have to remember the speed of the interface when you're going into interface configuration mode. You can always again do that show run to get you back to see what kind of interfaces you actually have at each location. Now we haven't made any configuration changes here yet, but it's a good place to talk about saving your changes. So, we just did a show run, and there are 2 files that we need to keep track of inside of a router. One of those is the running configuration, and that's what we just did. We did a show running configuration. You'll notice that we are abbreviating commands as much as possible to the point where they're unique. So show run instead of show running dash configuration. And the other one is startup configuration. So when your machine starts up, it goes and pulls the startup configuration file and it copies it over into the running configuration file. Now, if you make changes while your router is running, and you have a tendency to never turn your router off, then you make those changes to the running configuration. When you need to save that configuration back to the router, you're going to need to copy your running configuration back to your startup configuration, because if your router is turned off, you lose power. It's going to go back and pick up that startup configuration file, and it's going to copy it over into the running configuration file. So the way to save here is to do copy, run, start, and you'll notice that the destination file name is startup-config. And then we get this building configuration and OK, and that indicates that we've actually saved stuff. Now, if you're using Packet Tracer, you have to save this configuration inside of the router. When you go up here and you do a file and you do save up here, this is saving the overall topology, but not the configuration inside of each individual router. That's a big sticking point for students, is that they don't save twice. For each device that you configure on here, you need to save that, and then at the end of all of that, you need to save that Packet Tracer file. So I'm just going to call this the Secure Network Topology, and we'll go ahead and save this here as well. So we now have saved a configuration on this one particular device that doesn't save it on any other device, just saves it here. Now we're going to go back in and we'll get back to the command line interface, and now we want to actually make some changes. So we're going to go into global configuration mode, and to do that we're going to type conf space T. So configure terminal is the command, but conft is the shortest that we can abbreviate it, that it's unique. Now, we want to go ahead and provide a host name for this router. So if you notice on the prompt at the left here that it says router, and it shows that we're in global configuration mode now that we did the conft. But, if we have multiple devices open in real life, and they all say router, which it's not going to be easy for us to know which device is actually open. So we're going to call this one Lex Edge. And you notice that when we did this host name Lex Edge that the prompt now changes and it says Lex Edge. Now I'm not going to actually save this configuration, but you do need to get used to saving fairly frequently. Now we want to go into interface configuration mode. We actually want to put IP addresses on the various router interfaces. And you would remember from previous experience that you would have is that every router interface has to exist in a different network. So we'll be putting IP addresses that have different network portions on each of these devices. So to get into interface configuration mode, we're going to do INT, and then we have to do which interface that we're going to configure. Now, It's been a couple minutes since I did the show run, but if I remember correctly, we have the Fast Ethernet interface is the one that's actually configured out to that laptop. I hope that's still the case. So we'll do int fa0/0. That's abbreviating Fast Ethernet 0/0 to its shortest. And now you're going to notice that it says config if, which means that we're now in interface configuration mode. And so we can put in the IP address, and IP space ADD is the shortest that we can do to spell out IP address, and we'll do this one at 11.10.10.1. And in our topology here, we've got this subnetted out so that it has a class C IP address on it. And this interface has never been configured, so it's obviously the interface is down. But anytime we make any changes to the interface configuration, it is going to automatically go down if it wasn't already. So we want to bring that back up. Now, with a lot of the router configuration stuff, if you want to negate a command or sort of do the opposite of a command, like here we want to bring up the router interface, and the router interface, the command to shut the router interface down is shut down, so we want to bring it up. So we want to do the opposite of shutting it down, and so the command we want to use here is no shutdown. So we could type it all out, or we could just type no shut. You will notice at this point that we're going to get a we're going to get a interface status message here that says that the line protocol has changed state to up. So now we've got one interface configured, and it's now up. Now we've got quite a few other interfaces here that we need to configure, even on, well, actually this router only has two interfaces on it. So the other interface that we have here is this one here. I'm going to go to View, and maybe it's Options, Preferences, Port Labels, and Logical Workspace. And I'm going to close that there. And the reason I'm doing that is just so that I can see, this is my FA0/0. Here I've got these are a little too close, so sometimes you might have to move your devices apart just a little bit so that you can actually see what the interfaces are. Okay, so we have this device here that we have partially configured. Let's go ahead and put our serial interfaces on this particular device. So we're going to, we could exit if we wanted to bump out of the specific interface configuration mode. The thing is that if you just start configuring the next interface, it'll just move into the interface configuration mode for that, so you don't necessarily have to do the exit there, but I want to do it now just so that we see that done. And the next interface that we want to configure is the serial 0/0, and we're getting that right from here. And you notice I specifically set up using this particular serial connection here with the clocking on it, so that I would know which end of this is actually providing the clock signal. So this one's actually clocking, so that means that there's another step that we want to do here. And so we're going to do the IP address for this one and the IP address, and I'm going to refer back to the network drawing that I started with here. This one is to be 11.11.11.1. And the subnet mask on this one is 255.255.255.0. You always have to add that on there as well. Now, I'm not going to no shut right now because this is a serial interface, and this end of the serial interface is providing clocking. If you're connected to a real network, you're going to find that the service provider is going to provide the clocking for you. But if you have to connect two of your own internal routers together, then one of those ends has to provide a clocking signal. And to do that, we're going to do clock rate. And we're going to make this a 56 kbps line, so we're going to do 56,000 here. Now, depending on which router, so there's a lot of inconsistencies. Like most of the Cisco routers, most of the things work the same from one device to the next. It's pretty consistent. But every once in a while, clock rate will need to be one word, and sometimes it will need to be two words. And so you just have to kind of try the one, and if that doesn't work, then you can try the other one. Now, we need to go ahead and do a no shut here, because that's what we always do when we make any changes to the interface. The thing is that this is a point-to-point network, and there's nothing on the other end of it from its perspective right now. And so it really can't come up. Now, Ethernet interface doesn't have that limitation or that property, but point-to-point networks like serial interfaces do. Both ends of it has to be up. So we're going to do no shut net now, and it's going to actually send you a message saying that it basically couldn't bring that interface up. So it says it changed state to down. It's just the generic way of saying that it couldn't get it back up. And so when we actually, on the other end, when we actually program that one and we bring it up, then this one will come up as well. So that gets us our first router configured. I mean, it's just the interface configuration. Now, what we want to do here is we're going to configure all of these routers across here, and then we're going to start doing some connectivity testing, but we'll get to that in just a moment. I think I will do a copy run start. Now, I'm actually in interface configuration mode, and there's some things you can do inside of particular modes, and there's some things you can't. So let's say I wanted to do a copy run start here. It's going to say invalid input detected right at the word copy, and so we're in the wrong mode to do a copy run start. So what I want to do now, on the newer, like the 2000 series routers and later, you should be able to use the command do copy run start. And even though this isn't something that's native to this particular mode, it will still allow you to do that command. So the do copy run start, and we can do things like do ping and so forth that allow us to do some of those user exec mode or privilege exec mode commands here inside of interface configuration or in global configuration. A couple of other things that we want to do. Let's do a show IP int brief, and that's going to show us that our fast Ethernet is configured with 11.10.10.1. It's okay, it's manually configured, the status is up. These others are administratively down. Serial 00 is configured with an IP address, manually configured. Its status is down right now, and that's just because, again, we don't have a something off of the other end of that. You can do show IP int, or let's do show IP int, and you get lots and lots of information about it. But it's easier to use just the show IP int brief to figure out whether your interfaces are actually configured correctly and whether they're up or down. Okay, so what we want to do now is we're going to actually do our copy run start here to save, and we're going to move on to this particular device. Now it's a little confusing here with the way this here is, and what I'm going to do really quickly here is I'm going to go back over here, and I'm going to call this one Lex Edge. And let's call this one Dayton DAY Day Edge. I'll call this SNT Edge. And this would be our global edge. So now let's go into our Dayton and what we're going to do is we're going to do hostname DAY Day Edge. And we've got a serial 00, a fast Ethernet 00, and a serial 01 that we are going to need to configure on this particular router. So I'm going to do that really quickly. We'll do int S00, and our IP address here is going to be 11.11.11.2. And there's your subnet mask. Now, you know, this interface here does not have a clock signal next to it. So we should be able to do a no shut, and you'll notice that the interface actually changed state to up now. And you'll notice that there are green lights on both of these here that happened whenever we did the change state to up. Now don't worry too much about the color of these lights. I mean, they can be green and it still not work. So a lot of students, you know, they look here and they say, oh, there's green here, and both these are obviously working. Well, they're not configured. But you know, this particular Ethernet protocol here will kind of bring the interfaces up without them actually being configured on both sides of it. So anyway, back to our Day Edge here. We need to configure. So we got the serial 00, and so the next thing we want to do is we'll do int S0/1. And the IP address on this one is 11.12.12.1. Subnet mask is there, and this one does have a clock signal on it here. So we need to do clock rate, and we'll do the same 56,000. And we'll no shut. And again, it's going to go down because the other end of that connection is not up. Okay, so the other interface that we have to configure here is our FA00. So we'll just do int FA0/0. And the IP address here is 11.12.13.1 with 255, 255, 255, 0. And I skipped the dot here. Let's see if this... And that works. And we will do a no shut on this interface. And that will change state to up. Now I also want to simulate a Ethernet coming out of here. Now we can do a cloud which puts it out to the real internet. That's not really what I want here. I just want to have an address that I'm going to add in and pretend that it's the internet coming off of the date and edge. And to do that, I'm going to use what's called a loopback interface. So I'm going to do int LO loopback 0, LOZ, excuse me, LO0. And I'm going to do an IP address on this of 1.1.1.1. Now what I'm doing here is masking this off so that only the address 1.1.1.1 will be responded to by this date and edge. This is a totally logical interface. It doesn't exist physically. It's just an IP address that I can ping from anywhere on this topology, and I could go back later on and put another interface card in here, and that would be my internet connection, and that way I can have everything sort of ready to go prior to that. So that's what I'm doing here, and we'll do a no shut here. It actually changed state to up as soon as I created it, because it's a logical interface. Now, a couple of other things that I want to talk about briefly here in this first portion is that we want to hit that again. If this is a logical interface, if I wanted to get rid of it, I could do no int hello0, and that would actually take it off. Take all the configuration off affiliated with this. I'm not going to do it. I'm going to leave this one on, but I just want to show you that command there. If I wanted to change or take the IP address off, I could do no IP add 1.1.1.1 255.255.255.255. That would actually remove the IP address. And so if you accidentally put an IP address on, you just put the no command in front of what you just typed, and it will remove it from it. So I'm not going to do either one of those things now. I just wanted to show those before I moved on. So the next thing that we want to do here, I think we probably need to do a copy run start, don't you think? save the configuration on this particular router, and I think we're probably done here with this device for now. Let's go over to Cincy Edge, go to the command line interface, and we'll do enable, configure terminal, host name, and call this one Cincy Edge. Interfaces that we have here are S0/0. That's where we'll start. Go to 00. Oh, let's not do that. Let's to make it less confusing here, let's exit. Let's do S0/1. So we're working kind of from left to right across to here. And we need to look at our IP addresses. The IP address here is 11.12.12.2. And this is not a clocking signal, so we don't need that. Let's do another shot on that one. And you notice this one goes up, and then the one off here off of day edge goes up now. We have a I want to keep these looking good, but I also want to make sure I can actually see what's going on here. So we have a fast Ethernet 0/0. The IP address of that is 12.12.12.1. And we'll have to put the word address, IP address, and now shut that interface, bring it up, and then we'll do int S0/0. And the IP address of that one is 11.14.14.1. And clock rate of 56,000. We'll no shut it, even though it's going to go down. We'll do copy run start, and let's move on to Blue Edge. Enable config T. Let's do hostname first. Go to the int S0/0. And the IP address of that one is 11.14.14.2. And just a second, now it does not have a clock on that end. So we will Notice it's up now. And let's do the int fa0/0. Happy address of this one is 15.15.15.1. And we'll shut that interface. Okay, so at this particular point, all of our routers at the top of our topology are configured. We're going to do a couple of other configuration tasks up here. One of those is to, did we save this one? I don't think we did. Let's do copy, run, start. Let's go up to this particular server here. We'll go to the desktop on it, and we'll go to the IP configuration, and we'll do this one as a static address. We want to do just this one is 15.15.15.2, and we'll do a 255.255.255.0 on the subnet mask. The default gateway is 15.15.15.1 because that's the closest router interface. That's this router interface here. So, and then we can go here and do to make sure that those things are all made it into there. That's on the desktop in the command prompt. And let's go over here. We'll do desktop, and we'll do IP configuration on this one. This one is 12.12.12.2 and 255.255.255.0. The default gateway of 12.12.12.1. And then if we go command prompt here, and we'll do our ipconfig/all. Whoops. And those things are all there. And we'll do the laptop the same way here. Let's do 11.10.10. Whoops. 2. 255.255.255.0. 11.10.10.1. And we actually can do a little bit of troubleshooting here. Let's go back into the command prompt really quickly. We can ping our default gateway here now to make sure that we're getting down to the router. So 11.10.10.1, and that works. And we can do the same thing here. 12.12.12.12. 1. .15.15.15.1. So each of these devices is connected, to each of these routers, and that's what we're determining from our ping. Now we actually want to go back and do some troubleshooting across the top here. We'll go back into the Lex Edge here, and we're going to try to ping from Lex Edge to 11.11.11.2, which is the day edge interface right here. Now, you'll notice that that's 100% success rate there. So we might think, well, why couldn't we just ping from here to .11.12.13.1, for instance. That is this side of the Dayton router, and you notice that that's not successful. And so what you can always, once you get both ends of the network here, your point-to-point network connected, you can always ping to the opposite side here. But to get from this interface to this interface, then we actually have to go through the switching portion of the router, and to do that you have to have either static routes or you have to have a routing protocol, and that's going to be the next thing we're going to do here with these devices, is that we're going to create, we're going to add in a routing protocol. Now, if you want to do learn static routing and some different routing protocols, there's other resources available here to do that. But what we're going to do in this example is just a simple routing information protocol, and that's going to do exactly what we need to get this topology created. Real life, you probably aren't going to use routing information protocol as your protocol of choice. It's just that it's really easy here for starters. So we're going to go into global configuration using CONFT, and we'll do router RIP, which will put us into our router configuration mode. We're going to type version 2 because we want this to be in RIP version 2, and then we'll do network, and we are working on Lex Edge, and so there are two directly connected networks. We have 11.10.10.1, excuse me, .0. The network number is always the .0 number, or the first in the range. I should not say the .0, but the first in the range. And then we have 11.11.0. Those are our two networks. Now, the way it records this, it actually puts it back to, this particular IP address is a Class A address, and so it would default have a subnet mask of 255.0.0.0. Don't worry about that. Always go ahead and put the two directly connected networks in, and that way you get practice of what really needs to happen each time. It's just that when you do a show run here, it's going to look a little odd because you typed in router rip, you typed in version 2, you typed into 2 specific 11 dot networks, and it's not showing you those. It's showing you, and that's just a sort of a legacy programming piece. It has both networks in there. It's just it doesn't display it here. Okay, so let's do a copy run start. Do copy run start, and we've done this for LuxEdge. Let's do the same thing for our day edge. We'll do enable config T, and we'll do router rip version 2, and we'll do network 11.11.11.0, and the other one that's connected here, the others that are 11.12.13.0 and 11.12.12.0. Do copy run start. And now we're going to do SNT and do router rip version 2, and we'll do network 11.12.12.0 and network 11.14.14.0 and network 12.12.12.0. Do copy run start. And we'll go into LuxEdge, enable config T, and we'll do router rip version 2, network 15.15.15.0 and network 11.14.14.0. Do copy start. Now, so we have configuration across the top of the network here. And so let's go to the command prompt of this laptop up here and see if we can ping 15.15.15.2, and we can. Now, if we couldn't, what do we do? Well, so the most likely thing that you've done if you can't ping is probably put an IP address incorrectly. So what you want to do is go back to each of these routers between here. You'll do a show run to determine whether or not that they're correct. And you probably want to do a if you can ping from here down to here, try from this router here, see if you can ping from here to here. If you can, then try to ping from here over to here, and then try to divide and conquer to see where the problem might be. And And you're going to check on things like, are the interfaces up or down? So you'll do that show IP int brief, and as simple as this topology is, it's probably that you've typed in an IP address incorrectly, so you've transposed a number or something of that nature. But always ping to see how far you can ping, and then kind of focus on the area where it doesn't seem to go through. Okay, so that gets the top of the topology done, and I think that's probably enough for episode 1 of the secure network topology. And so we'll come back and we'll do sort of the bottom half of this topology, along with setting up our VLANs next.